Okay, good morning everyone. Nice to see so many of you here, even though it's only 9 o'clock in the morning. My name is Leena Hallin-Pihlatie. I'm chairing this session. I have invited speakers for today's session that are doing interesting things related to land cover and land use themes, the Inspire land use and land use themes. We are going to hear about the activities of EAA and of the European Location Framework. And then we are also going to hear a presentation related to Inspire planned land use. And the timetable of today is that we can focus on land cover and existing land use until 10 o'clock, and then from 10 onwards we will focus on planned land use. Before I give the floor to my invited speakers, I would like to use the opportunity to give a short introduction to the Inspire thematic clusters activity. As I act as the facilitator of the land cover and land use cluster. This activity has been up and running since December 2014, and it is an open collaborative platform to support the thematic communities to implement Inspire and to resolve issues together and to help Inspire to evolve in a direction as the thematic communities want. This activity is part of the Inspire maintenance and implementation framework. So it's work package 14. There are 9 thematic clusters, and for each Inspire theme there is a subgroup. There are 9 facilitators that are chairing these clusters. This doesn't mean that these facilitators have all the answers. Of course, we try to provide the answers and we try to link people together. So we keep track on questions and try to get hold of people that we try could give the right answers for that particular question. And with some group statistics, I would like to show what's already in there. So at the cluster level, there are already over 100 members. Lots ongoing discussion topics and so on. And you can all use this information by Googling or searching for information in the land cover and land use themes. You will probably land on some of these cluster pages. In the subgroups, there are not so many members, but as you can see from this slide, there is a lot of discussion going on also on this subgroup level. So, and in order to get information about these ongoing activities, news, new discussion topics and replies, you need to register and join the groups. So I would encourage you to do that. And I would like to ask how many of you have already joined. Yeah. Nice to see that so many. And the way to join and register, you first have to make an account. Here are instructions. You have to be registered to the ECAS platform, and then you can join a group. But I would recommend you to join at the subgroup level, not at the cluster level, but to go to that particular theme that you are interested in, because then you are also automatically a cluster member, and then you don't miss out on some interesting thematical issues. You can also change your settings and put a nice picture and what you want, describe yourself if you want. And if you think you get too many emails, then you can also take the email notification off. Then to the highlights of the content so far. I think the discussion topics are the highlights, because there people really raise the issues that are of their concerns. And actually, these discussion topics have helped in documenting and resolving software issues, because there are a lot of software developers on board. So this really is a way also to improve the softwares and to get feedback to the software development community. Here are some examples of discussion topics: how to understand code lists, how should Inspire data look like, how to name the layers in WMS services, and how to build Inspire-compliant web feature services. Based on these discussion topics, a list of preliminary proposals for change has also been compiled. Other content highlights, I would say, is the sample GMLs that are out there. There are sample GMLs for land cover vector, existing land use, and also an example of an S3 database, which they have made based on the land cover vector model. There are matching tables filled in for Corinne land cover and Urban Atlas, and also sample data sets, sample GMLs for Corinne land cover and Urban Atlas. And the main sources for these are the Eagle Inspire and Ian Plus projects of last year. At the landing page of the thematic cluster platform of land cover and land use cluster, you also have the links to relevant Inspire presentations. They are not so easy to find, so we had tried to make it easier for you to find the presentations of relevance afterwards. And a practical hint for using this platform: use tags and categories to find the information, but also if you provide, or when you have registered and joined, you can provide new content, and it's a good way to help others to find the topics. So welcome to join this thematic cluster activity and discuss and raise issues that are important to you. Would you have any questions to me about this activity? I would ask you to wait for the mic, if you put up your hands and wait for the microphone, please. Okay, let's then move on to my invited speakers. I would like to thank them all very much for being here and for using their valuable time to give these prepare presentations and demos for us. The first one up is Christian Ansorge. How do you spell it? How do you say it? Okay. From the European Environment Agency. And he's going to tell about the recent developments of the Copernicus land products. Please, the stage is yours.
Just forward, backward.
Yes, and you can use this if you like.
Okay, thanks. Thank you very much. Thank you, Lena, for inviting us. I would like to go back to the thematic clusters and just to give you the feedback that we consider that this is really a valuable contribution to the community. So this is the place where if you have questions, if you want to discuss, if you look for something, please go there, express yourself, answer questions, join the discussions. This is really one of the big results of the last 2 years, and we are happy to support this. So yes, my name is Christian Ansorge. So I'm from the European Environment Agency, and I'm here to wrap up the recent activities around land cover, and especially from the viewpoint of Copernicus. So what are we as Inspire team doing with land cover data and together with the Copernicus team? I went back to 2016 in Lisbon, and those who have been there and have a very good memory might remember that there was a similar presentation with a similar name, and I found it a little bit interesting. So I wondered myself, Copernicus land products on their way to Inspire. And yes, they still are. We are going with tiny steps, one after the other. And maybe next year I can tell a little bit more. So here I'm to wrap up what we have done so far. To go back in 2015, where we did, with the support of the Eagle Group, a study on the transformation rules for land cover products. This year we launched 2 studies to support the development of services. So I will go more in details, also around the consumer side, around GML and QGIS consumption. And 2017, I will not do this mistake like last year and announce that in the next year we will have full-fledged services. But I hope we are closer to our landing zone. Our landing zone is that Copernicus would like to provide their data according to the Inspire standards. This means this web service described as metadata, and we are not fully there yet. Let's go back in time, 2015. You might have heard in 2015 the EA, together with the Eagle Group as consultants, launched a study on transformation rules for 2 major land cover products. The first product was current land cover, so namely the current land cover 2006, but the data model is more or less stable. And the second one was Urban Atlas. So for these 2 land cover products, we wanted to develop the mapping tables. So we wanted to know how these products have to be mapped against the Inspire data specification, namely land cover. We asked for sample transformation and for validation. And just to wrap it up, you might have heard of that already. The data is available under this, or the reports and the work is available under the URL you can see. So there you can find the mapping tables, extensive reports with the experience and the lessons learned, and sample transformation, sample GML, which gives you a taste how land cover products, CLC and Atlas, should look like in the Inspire data specifications. Now we are coming to the present. So this year our focus were on 2 studies which we have launched. One coming more from the Inspire side, and the other coming more from the Copernicus user perspective. So typically we were kind of confronted with the situation that it doesn't make much sense to provide data because right now we not have the tools to consume them. So this has developed over the last 5 years, and I heard it all over and over, to a kind of chicken egg problem. So these 2 complementary actions aim actually to, on the one side, provide ways and best practices how to publish data, and on the other side they should also support the consumption of data. I will come a bit more into details. So the first is a feasibility study on benchmarking of Inspire network services. So here we work together with the Kio Leuven, Epsilon Italia, so namely Stefania, who will have also a presentation, and WeTransform, Thorsten Reitz. So here, and the scope was to test several of the available software pieces to provide WMS and WFS, to test them in special scenarios, also to see to what extent they can be used in software like ArcGIS or like QGIS. So we had, it's not only about land cover products, but of course, current land cover is one of the cases. So we split it up. We tested Degree, GeoServer, ArcGIS, And on the data side, we had 3 cases. We had current land cover, which is a pan-European data set with a low complexity of the individual features, but a very, very high number of features. So we are up in the million of number of features. So to contrary to that, biogeographic regions, the second case, here we have only 12 polygons. It's also a pan-European data set, but those 12 polygons are enormously complex, have each of them around 500,000 vertices. So this also is a challenge. And the last case we tested with all the software was CDDA, the common database for designated areas. And this is based on a data model which is extended. It's a protected site data model which has been extended by the agency the last year, and we wanted to know how these services support extended data models. So not just vanilla Inspire, but if I have to adjust it to my use case. And just to make the story short, this on a very high level summarized is the result. If you have any further questions, I assume you have them. There are 2 ways to inform yourself. First of all, I would like to invite everybody to come on Thursday, the 29th, 4:30 to the presentation of Stefania, who did the major work on this study, view and download services fit for purpose. In the agenda, you still find my name as an author, simply because of the reason I wrote the paper, and afterwards I was not able to change the main author. The second way to inform yourself is to have a look at the project results. So here we have 7, the screenshot is short, and we have 7 reports on all the cases we did, including the testing. And these are freely available. Please have a look, please provide feedback. We would be very happy to further develop the study. If you have valuable feedback, corrections, suggestions, we will take them up. Yes, the second piece of this year's activity is the support of GML in OGR. OGR is a software library which is used in QGIS, also in ArcGIS, for example. And our work was focusing, the work of Titilus and BRGM, which are here the main actors. Copernicus is funding this activity partly. So the scope is to further develop the OGR library to provide a better support for complex feature GML. And the overall goal is to demonstrate this in a QGIS plugin where you should, in the end, be able to, out of the box, consume Inspire services. Here again, there's a presentation of my colleague François Brunet with this name. It's tomorrow, 3 p.m. So you're also invited to go there in case you have further questions. So here, this activity is not finished, so it's on progress. And François informed me that he will have a demonstration of that. This brings us to the future. And I said I will not make big promises how next year will look like. But clearly, we have the intention, together with the Copernicus colleagues, to build on the results of the study of Stefania and the KU Leuven to further develop services. So here, right now, we have only WMS on the Copernicus land products. We would like to extend this A to Inspire conformance services, and B also to include WFS. It is a step-by-step approach, so we will not implement all land cover products next year. So we will for sure start with current land cover, because there we have the testing laid out. We will look into the time series. Current land cover is not just a single product, so there we have a time series, we have change layer, we have vector, we have rasters, and then we might also extend to other land cover products like Urban Atlas and other Copernicus products. In the end, together with, we consider that by the next year we are hopefully able to better provide Inspire data, and hopefully able finally out of the box and for normal GIS customers to consume Inspire services. We suppose ourselves as very happy. So thank you very much. And I would like to give the floor back to Elena, and also put a highlight on Stefania, who will later on demonstrate a little bit with current land cover. And one of the important pieces, and then I stop talking, please be aware, right now we have, for the first time, a pan-European data product available on Inspire services. So this is what Inspire, what Stefania will show. Thank you very much.
Christian. Is this on? Yes, thanks, Christian. Nice to see that you have proceeded so well. Yes. And did I understand you correctly that you already have a network service running?
Yes.
Would it be possible to share the link?
Yes, you're welcome. As I showed, there are two ways to form yourself. On Thursday is the presentation of the project results, more details. The CLC for Help Me Degree is publicly available, so they are on degree service. Thanks. Sorry. We have a web service on degree, publicly available on Epsilon Italia. Yeah. Yes. What will be live demonstrated in a few yeah. So this is the big message. While last year we still said we would look into services, this year with the support of Stefania and Epsilon Italia, we were able now to have a testing instance for Land Cover 2006 vector data. So not full Land Cover, but 2006. And on that we will test, we will benchmark, we will see, and we have to then to take a technology decision, which of the technologies we will go forward with. So, but right now Pan-European data set for the first time is online.
Thank you. Other questions? Then I would also ask about the technology decision. How can you say anything about that, or is it still completely open?
For that we have to further test. So we have to look into the two possibilities which we come out of the studies. The one is to use degree, maybe. The other is to use ArcGIS. So for ArcGIS we have to do further testing. So at the moment I cannot tell much about that. Also, we have to discuss with the Copernicus colleagues what they use in house and what is their preference.
Okay, thank you. Thank you very much. And now it's time to look at the European Location Framework project, what they have been doing with land cover vector products. And I have Teemu here to tell something about that project. Thank you.
Thanks.
Okay, good morning everybody. My name is Teemu Solariutta and I come from the National Land Survey of Finland. And our topic today is what we have achieved in the ELF project considering the land cover vector products. And first a few words, what is the ELF project? So it comes from words European Location Framework. It might be familiar to some of you. I see some of my colleagues who are participating in the project. But for those who are not familiar, it was a 3-year project which is now in the final stage. We are having only 1 month left with the project. And it has been running for more than 3 years now. And the main goals are to deliver a pan-European cloud platform and web services that build on INSPIRE schemas. And also we would like to enable access to harmonized data in cross-border applications. So basically we are implementing INSPIRE compliant web services and try to make them accessible through, for example, ELF Showcase application, which I will show you later. This image is from the Showcase application interface. And there are more than 20 countries participating and many INSPIRE teams covered. Of course, not all countries are creating web services for all of these teams, but at least land cover, for example, is covered by, I think, 4 or 5 countries only. So this is not like such a complete project that every 20 countries are delivering the whole Inspire services. But this is a good practice where we have been trying the technologies, how to produce the Inspire services, and what challenges we have faced. We can then learn when the actual Inspire deadlines are coming next year. So, as I mentioned, we are using the Inspire schemas, but actually some teams have a specific ELF schemas with minor extensions to Inspire. But for land cover, we are using directly the Inspire schema. And one important note about this project is that the most ELF project partners are national mapping and cadastral agencies. So they are not necessarily the best source for the land cover team. There might be, for example, environmental organizations who have better data for that land cover team, but still it's the national mapping agencies who have created these ELF download services. So this is not like the final Inspire service for many countries. So if there are other organizations that have responsibilities for this team, then the actual Inspire service has to be created later on. And currently, land cover is delivered in the ELF project by Finland, Sweden, Norway, and Denmark. And I know that there are other countries as well who have activities delivering this team, but these are currently available. And then a few words about the technical infrastructure. So basically, each country is having its own data, of course, and each country is setting up its own download service. But then, for the user, we have created a cascading WFS service, which basically means that we are combining all the WFS service created by the project partners in the one common endpoint. And it works so that when the user calls that common endpoint, then it automatically can deliver the request to the national service with the bounding box. So if you, for example, query data between the Finnish and Norwegian border, then the bounding box is overlapping the Finnish and Norwegian service bounding box. So then this cascading service knows that, okay, now I have to call both Norwegian and Finnish service, and then it returns the data on the screen. And this is a little bit off topic, but I just want to mention that land cover is one of the main themes presented in ELF topographic base map. This is not a vector data, it's a WMTS service. So it's basically a base map which has like buildings and roads and land cover and some standing water elements and stuff like that. So it's a base map, as the name says. And it was based on common data model and styling rules. And the picture is not seeing very well in this lightning, but you can see that there are some different colors representing different land cover types. So back to the actual vector data. And this is just an image from Finnish-Norwegian border, and it's not visualized in such manner that there would be different color for different land cover. So this is just download service data visualized with the black line. So it's not very informative in that sense. But you can already see that there are differences between the countries. So in Norway, there seems to be like 100% coverage on the data, but in Finland, there are just a few polygons. And this is because at least in the National Land Survey data in Finland, we don't have forest data. And we have it as a background color only, so we don't have the actual polygons for forests. But in Norway, it seems that there are polygons for each land cover type. And it's also, you can see these like straight lines in the Norwegian side. And I think there are some kind of technical borders, because otherwise you would have a huge polygons presenting forests or whatever feature type it exists. And when you click these objects, you will see actual feature classes and lifespan information and stuff like that. And by clicking this link, it will open an XML file with all the descriptions, what kind of data it is. For example, in this case, it means that this value 21 means that it's open vegetated area. And this classification is not created from scratch, of course, but it's based on concepts from this PLCC and Eagle Matrix, which are implementations of this ISO standard. And it also, let's see if I can click this link, so we can see how the documentation is in the location framework web page. Yeah, so it works. So there is basically a list of all possible land cover values that have been used in this project. And for example, this open vegetated area has its description here. Oh, it's not visible on the screen, sorry.
You have to drag it on that side.
Oh, that's better. Yeah, so the open vegetated area is described in here. Okay, the text is so small that you can't see what's there, but anyway, this is how this code list is documented. Okay, we can go back to the presentation. And the actual pictures I showed you, they were from this ELF Showcase application, and it was actually open for Quest users yesterday. So now it's possible for you to look at these services, but I will show you a brief demo so that you see how it works. And so this is only for viewing purposes right now, but the download services will be available via ELF License Manager later. So currently you can't access the download services, but you can view the data via this Showcase application. Okay, now it works. So all the available layers can be seen in this Map Layers tab. They can be sorted by team or by organization. And if you click this By Data Provider tab, then you will see this ELF data provider, which has these cascading services. So you can access all the services with one endpoint. And let's find the land cover. So there is feature type land cover unit, and it's the only one about land cover theme. And because these services are quite heavy, we can't download all the data covering the Europe with one click. So we have to zoom in and then click refresh button to download only the area that is visible on the screen, and then it will work. Okay, let's go to the Finnish-Norwegian border, as I know that the data is available there. And this is a little bit hard to know, that you can't know exactly where each service is available, so it might be difficult for users to get to find the actual data. But now as I just happen to know that it exists here, we can start with that. Now the refresh button on the right low corner is red because you have to zoom more in to see the data. Okay, now it turned gray. Now you can click it. Yes, it works. And now you can click the actual land cover polygons to see this feature info. Yeah, it works. So now you see this link for the land cover classification and then lifespan information and some local ID. There might be another columns in the actual data, but this showcase application is parsing only these ones which are available for all countries. So there might be some differences in national services, but we are showing in the showcase application only those that are available for all. Okay, that's all. I can show you one last slide and then I'm done. So ELF download services are INSPIRE compliant pilot services, and the source data is not consistent between countries and not necessarily delivered by the same organization that is responsible for the actual INSPIRE services. And the data is not covering 100% of the land area in all countries. Yeah, that's it. Thank you.
Thank you very much, Teemu, for a good presentation and real demo on things. You must have encountered challenges. Did you encounter some particular challenges related to land cover theme?
Yes, actually one technical challenge was the land cover dataset feature type, which has like a link to land cover units. And then it caused that if you try to download the land cover dataset, it actually tries to download all the land cover units on it, and then it crashes the service immediately with that huge number of feature types.
Thank you. Any other questions to Teemu? Wait for the microphone, please.
Yeah, thank you, Teemu, for the presentation and some Finnish examples how the data set actually looked like in the national data sources. And it was funny to hear that you don't have polygons for forest, but just use it as a background. So that means that you assume that the background noise in Finnish landscape is forest.
Yeah, it's a little bit a funny thing. I think it's from the mapping history that it was cheaper to print maps with forest as a white color because there was most of the land area is covered with forest. And then it still exists in our database because we are a mapping agency. So the database structure is designed for mapping and not for this kind of purposes.
Okay, my actual question is, if you're saying that not 100% of the area is covered by land cover features, would it be helpful to have something like a pure land cover component called unknown land covers, where you can, as a placeholder, just to have a polygon with no information, but still be able to have a clean topology of the whole data set and cover 100% of the area, even if some of it is unknown?
Yeah, that sounds a good idea. I think that it would be possible to create something like that. Of course, if you would create a huge polygon covering all these unknown areas, it maybe would have to be split up into several pieces to be possible in the database.
Thank you.
Thank you. Any more questions? Thank you, Teemu, very much. Yeah. Then we will continue with the presentation of Stefania Maron, that has already been mentioned before. And it will be, we will see some really interesting demos here, hopefully. Okay, you're welcome.
Okay, thank you. So good morning, everyone. My name is Stefania Morone. I work for Epsilon Italia. And today we will see an example of validation and use of an Inspire Lankover GML dataset. Just an outline of what we are going to see. Just 2 slides to introduce the harmonization process we did to derive a Lankover GML dataset compliant to Inspire Lankover vector application schema. And, but we will see that we validated also against requirements included in the ATS for Lankover, included in the Annex A of data specifications. So to derive this dataset from Korean Lankover 2006 source data. And then we'll go live with the demo. Hopefully it works because we had some troubles before in connecting, but anyway. We will see how the GML dataset we produced displays in QGIS, how we can use get-info tools, and we will validate the GML dataset. Actually, we will see a subset because for time reason, for the sake of brevity, I selected features from Portugal, and we will validate this subset in the EMV Plus validation service. And then we will see that WFS were derived with degrees for Lankover. Actually, also WMS has been derived. And we will see how WFS features can be imported and queries in QGIS environment. And we will validate the WFS served feature structure with the EMV Plus validation service and see if the served features have a structure that is compliant to the Lankover vector schema. So, which was our process? We started from Korean Lankover sources, and we used the shapefile and executed transformation, but then we also tested transformation using SQLite. And then we transformed by means of a Hail software tool. For the transformation, we referenced the mapping table derived in the Eagle project. So we used the same mapping for the elements from Lankover source to Inspire Lankover vector elements, application schema elements. And just we will see later, there is also one difference with, in the way we encoded the member relationship, between dataset and units. So this member relationship is very tricky for the land cover application schema, but we will see how to overcome this issue. And so we derived land cover GML, and we test everything in QGIS for usability. And then we used degree to derive the WFS services. We tried both options, two options, just to ingest directly in degree the GML we created by means of Hail. But in another option, we also tried to directly upload features from Hail project, Hail transforming project, directly to our degree instance on the cloud, and by means of WFST. And it works. So we derived our OGC services, and we tested usability in QGIS environment. One important thing. In the application schema for land cover vector, there is the member relationships linking the land cover dataset to its land cover unit. It's a light aggregation. This means that there are two options to encode this association, this aggregation. On the right, you see a screenshot of the Hail workbench for the target. And here you see in the green box how the land cover dataset can be linked to this member by means of X-Link href. But also, just below, you can see that you could also embed the description of land cover units directly in the land cover dataset. So don't do that if you want to be able to test in QGIS environment. Why? Because if you select the first option, that is you address land cover unit by reference, you are able to create a GML in which the land cover units are separate GML members. So QGIS is able to see the GML land cover dataset feature, and then all land cover features, GML land cover features, so it is able to display. Instead, if you use the embedded description, so you derive description. So let's see if it works. Yes, works. If you use this land cover unit, so you specify the transformation from land cover units elements. Thanks to this, you are not able to see, because the GML will contain one GML feature, that is the dataset, and description of the unit is nested in the description of the dataset. So QGIS is not able to see the other members. So what you will get using the other mapping, which is compliant to Inspire, and there is an interesting discussion on thematic clusters on this. So go and see and visualize on thematic cluster, land cover, and use clusters. You will see only one polygon. So you will lose completely information related to the units. So let's go for a demo. How can I? Hopefully we can. Okay. So we will see. Okay, it's better to connect first to the EMV Plus validation service and upload the GML to get validation. Otherwise, it takes too long. We have just 15 minutes. So I can see, but I can't write. I can see here. Oh, where is the? I can see the window. Where is the window? It's there, but I can't type in the address.
Yes, it's, you have to drag it back, I think. Go over there. Doesn't it let you? Okay, where is it?
Okay, we cannot see here the window, and we cannot type in the address of the validation service.
Try.
I can. The address. It's an address. Cloud. Okay. Cloud. Dot. I will. Okay. Thank you. No. Where is the? No. This is not. Where is the dash? It is not in Italian. Yes. Yeah. Okay. Great. Epsilon Italian. Oh, Yum Plus validation service. Yes. Here it is. Sorry for the inconvenience. Okay. This is the Yum Plus validation service. Who has already tried it? Us? 1, 2, 3, 4 out of 6. Out of maybe 50 people, so not so many. Just a brief introduction. The validation service is able to validate GML dataset, actually also application schemas, against requirements of schemas declared in the GML itself, but it does much more because it is able to test also against other requirements of the GML data specification that cannot be encoded in an XSD because they cannot be expressed in XML schema grammar, such, for example, the orientations of polygons for geometries and other geometry testings, and also uses schematrons to test other theme-related requirements which cannot be expressed by means of XSDs. I have no time to go into details now, but you may ask later, and you can follow also a presentation that will be given on Friday in the morning, 11:45 in the morning, next Friday. We click. I lost it again. No. I try to close everything and see if it appears. It goes this way. Okay, if I cannot get it. I'm clicking on it, but it does not click, actually.
Would it help if you would make it ready here and then just drag it at the end to the other side?
Here. I cannot see it. It disappears. Drag it.
Yes,
okay.
drag it all the way back. No, it doesn't show.
It doesn't show.
It's not open. Now it's there.
The Google Chrome. Yes.
Here. It's just to
Yes,
drag it from there back here so that she can put the file in and then she can drag it back. Because it's hard to operate if it goes.
So maybe it's better you ask me later.
Want to minimize?
It does not show.
I don't know what you want. I understand what you want.
Okay, I want this window to display here because I have to click on.
Okay.
I can see it there, but I cannot see
Okay.
here.
This?
Okay. So, stay here, don't move. Thank you. So,
But then
we
remember
are not
that
able
you
to see
do
the-
it, so we have to change the subtitles.
okay. Okay. How can we do? Okay. I tell you what to do, and so you will test the MV Plus validation service by yourself. So.
Okay. Now it's all on the same folder.
Oh, thank you. That's great. Okay. Let's try. Don't go. Yes. Okay. So, clicking on the Inspire button, you are introduced to the the concept of Inspire validation. Some tests in Inspire data specifications are strictly related to the theme, so you have to select the Inspire theme you want to test. In this case, is land cover. And you are introduced to a page where you can see all the tests that are foreseen by the ATS. And for each one, you are suggested an executable test suite you can use to test the requirements listed on the left. So this morning we will see what can be automated. So automated validation. Here again, we have to go very fast. You can have a detailed description of what is going to be tested and how. And then you have to log in to execute the test. Okay. Okay, don't. Okay. So, after you have logged in, you are able to specify which test you are going to perform, which geography markup language. And so, we can directly upload, for example, here, a string, a WFS string. We will see how to, hopefully, we don't know, how to insert a WFS get feature and validate features served by the WFS, or choose a file, and then, so on C,
Look on the computer.
desktop, and then see computer, and then local disk, and LAN cover workshop. And here it is. I selected 100 features from Portugal. Then you can just select a GML file and test. In this case, you will test only requirements related to the LAN cover vector application schema and GML application schema, and other requirements from ISO 19136. But you can then, and in this case for land cover theme, the schematron is available. You can select here land cover vector schematron to test also the other requirements from the implementing rules, which are not encoded in land cover vector application schema. So you can start the validation. It is uploading. while it is working, we may see maybe in QGIS what happens when we try to see the GML, just to optimize times, okay? This is how I just imported the GML in the QGIS, so drag and drop the GML. But what happens? In this case, if I try, so let's go to the unit. Let's, avoid the dataset. So if I use the info, and what happens? I'm not able, if I just pick my GML, so drag and drop in, I'm just able to see few fields from the GML. That is the ID, the GML ID, the local ID, the namespace, and lifetime information. So I'm not able to see, for example, the class. And this is a pity. But there is a trick. Okay, you can use the GML, what is it? The plugin is not installed. So there is a plugin, GML loader plugin. Okay, it should have been installed, but okay. Okay, there are two plugins, GML loader. Let's search. GML loader. Let's see. Oh. Okay, you have to use, there are two plugins you have to get installed. I've asked for, but they are not present here. The GML loader and GML complex info. So you can upload the file, the GML file in QGIS by means of the GML loader. And so in this case, you are able to see also the X-link hrefs, so elements in the application schema, which are of href type, such as the land cover class information. 1 minute left, okay. And then by means of the GML complex info, you can click on selected features and get all the information that are present in the GML. Same things can be done for WFS when you import, and you need another plugin for QGIS, which is WFS 2.0 plugin, client, WFS 2.0 client plugin. And you are able to visualize by means of GML complex info all the information which are nested in the GML feature for land cover unit. So hopefully, okay, the M+ validation service has finished, and you can see that our GML passes validation. You can have, you can see details here of the test failed or passed. In this case, so hopefully all is passed, all tests are passed. But you are also able to visualize the report graphically. If we go to complete session results and test on detailed test report, you can have a list of the tests performed and the results. So I'm done. I am able for everyone here to have a demonstration later, and I will install on my PC, and we can have, and we can see it together. Thank you. I wanted to let you see another thing, but I have no time here. We can access WFS also in the browser. And one important thing that you get using the mapping by reference between dataset and units is that you can download very quickly the dataset because you are not trying to download the description of all the data units so that the WFS crashes. Using the by reference encoding, this is a very important thing. Using the by reference encoding for the member, you are able to quickly download the dataset because the members are just links. Then you are able to click on the links and you will download by means of a stored query information related to the unit. Ask me and I will let you see, okay? Thank you very much.
Stefania, stay on the stage. Thank you very much, Stefania. Good with the hints and these solutions on how to deal with things, to get things to work. How you encode land cover vector data really matters, and there are discussion topics on this on the cluster as well. And thanks for all these.
Otherwise, you won't be able to download the entire dataset because it's too huge. When you speak of land cover, millions of polygons, you will never be able to do that. So you will if you use the by reference encoding.
Okay, thank you. Any questions?
Thank you, Stefania. One question I had regarding the QGIS plugins you mentioned, WFS 2.0 and the Gmail loader. To my knowledge, those plugins are just flattening the complex feature structure. Is that right?
Yes, when they display, yes. But if you use also the GML loader, you are able to see the tree, so the nesting. You're able to do that.
I'm able to query there?
Yeah.
Okay.
But you have to use, you have to load GML into QGIS by means of the GML loader, and then use the other plugin, the GML complex info, and select feature, click, and then you will get.
Okay, thanks.
Other questions?
Hello, my name is Raquel Medeiros. I came from Azores Islands. You shown there Madeira Islands archipelago. In your example, you showed Portugal, but it's Madeira Islands.
Yeah.
Your example.
Yes,
And,
it's different. Yeah.
Yes, it's Azores is another archipelago. I have several questions for you, but I won't put them all here. I just wanted to know if you have any solution to map the alterations data sets we have in Portugal, CLC 90, 2000, and 2006. And between these years, we
different
have
observation date.
Yes.
Yes. You may ask me then later. I will show you. Yeah.
Okay. In the AL, you showed only the data set for the land cover, the schema land cover data set.
Yes, you have to map the land cover unit feature type, of course.
Yes, but you didn't show the nomenclature schema. Inside the land cover schema, you have three different features: nomenclature, data set, and land cover unit. Did you utilize all the three, or
no,
just
not the land
dataset?
cover nomenclature, because I embedded the land cover nomenclature in land cover dataset because there are no geometries there, and so I'm able to display in QGIS.
Okay, so you can
I mapped the land cover dataset feature and then the land cover units, and I obtained the land cover dataset by means of a merge operation.
Okay.
So the geometry of the land cover I obtained by means of a merge operation.
Did you put the two islands of Madeira archipelago inside the same feature, the same shapefile, or did you separate the two islands in two different shapefiles?
No, I used the same.
It's because in Azores we have two different coordinate a
Yeah,
few systems?
you have to. Okay,
have to introduce.
I will tell you. Ask me. I'm here. I'm here. Okay.
Afterwards.
I have a reply
Okay.
for you. Okay.
Thank you.
Thank you for the discussion, but we need to get further with the other presentations. So I would like to invite Morten Borrebekk from the Norwegian Mapping Agency. Please, go ahead.
Thank you. My name is Morten Borrebekk from the Norwegian Mapping Authority. I will use a few minutes to tell you about our experience on revising Norwegian standards based upon Inspire. The outline, I will give a short background. I will focus on the scope, the project goals, and the achievements. I have to say a few words about the Norwegian standard SOLSI. SOLSI is actually a set of standards, coordinated approach for spatial information. We do have a strategy, I'll come back to that. A few words about extension patterns, and in the end, some summary and conclusions. So let me start with the background. And we do have a standard for planned land use. We had several versions of this, and we have now agreed that we should make a revision. And doing a revision is a very good time to look into Inspire and how we should fulfill the requirements in the directive. We do, of course, have our own Planning and Building Act, which has been there for quite some time, long before Inspire. And of course, it's interesting to see how these fit together. We should look into synchronization with our digital planning register. We should look into modeling of planning decisions, synchronize with building process. And finally, we should update all our models according to the revised version of the international standards. Even that is actually a challenge, because Inspire is modeled based on previous version of the ISO standards, and in our strategy, we should model according to the updated version. So it will actually be a kind of a mix. And finally, alignment with Inspire planned land use. I will not be able to get into all these issues, so I will refer to another presentation, particularly on the 3D. It's a presentation called Improved Land Use Planning in 3D, Thursday at 2 o'clock. So I will only focus here in my presentation on the alignment with Inspire planned land use. A few words about the SOLSI standard. This is a set of standards that we have actually provided since the 1990s. Fully model-based, we started with the ER models, entity relationship models, continued with express models. For the last 10 to 15 years, we have used UML models. Based upon the same standards, maybe not the same version, but the same standards as Inspire is based upon. We have a model repository, a subversioned model repository in Enterprise Architect, same technology that Inspire use, and we have Inspire models as part of our model repository, but we have added our general feature catalog and all our product specification. We provide product specifications according to ISO 19131. That's the same standard as the Inspire specification is built upon. One more thing I would like to mention here, that we have made model validation scripts in Enterprise Architect that actually tests if the model are compliant with the standard. So you could actually get rid of a lot of errors on the modeling level before you start implementation. And we have a web view for access to the model repository. We have a national strategy. We have so many teams. We have 57 teams actually. Many of these teams aligns with Inspire. And in our strategy, we have said that our feature catalog shall gradually align with the specifications that is referenced from our Geodata Act, which is actually our national legislation of Inspire, but only where appropriate. Where it doesn't fit, there we really have a challenge. And of course, that was one of the very interesting issues when we looked into this. Will this fit at all, or how hard will it be? We have also defined some extension patterns. We have been part of the GeoNoven JRC project on extension patterns. There was a workshop on that yesterday. And we have actually looked into subtyping, the realization pattern, and also redefine, which is a specific set of inheritance. And we have also said that if there is no relationship to Inspire, it should be stated in the introduction to the standard. So there is no way to not look into Inspire. It has to be stated somewhere. Few words about the rules for extensions in Inspire. This is actually described in an informative annex. But of course, the generic conceptual model is informative for us. It's not part of legislation, but it is expected that member nations should actually look into this, aligning their models. And it's very general, saying that when you extend the Inspire specification, it should not change anything in the Inspire data specification, and you could not add something new concept that breaks with existing concepts. I will come back to that in my conclusion, how this actually fits. So this is our first attempt, using what we learned from the ELF project, using clean subtyping, and we see how our concepts in our existing standards fits as subtypes of the spatial plan, of the supplementary regulation, and the zoning element. And when we look at the official documentation, it fits quite well with our planning register. But this is the nice part of the model, what we show here. There's a lot behind this, a lot of associations between the classes, but the subtypes, which would really make this diagram a candidate for the Chamber of Horror of UML models. We have also tried to sort this out in what we call context diagrams. It's quite complicated, actually. The first thing we had to focus on was translation. We used quite a lot of time to translate Inspire concepts into Norwegian to really understand what this is all about. And also, this is a way of focusing on the context, showing each feature type, all the relations to that feature type, and all the code lists and data types that is applied in this context. And there is no big challenges in this, actually. Even the code lists are doable. Yeah, maybe I should go one back. One of the challenges is actually the associations between the three main teams or feature types: the supplementary regulation, the spatial plan, and the zoning element. They are very general. And if you look at the associations between the subtypes, they have a stronger semantics. That's mostly compositions and not simple associations. So if you should actually inherit these associations and at the same time continue with our composition, that would actually not follow the rules from the Inspire on extension. So the second approach is to make a realization. Realization is a very loosely coupling. It means, in the same way as a subtype, it means that you realize something from a class, in this case Inspire, but it doesn't really say how you realize it. You have a lot of attributes on the realized feature type, and you have a lot of feature types on the object you realize from, but you don't see the mapping between them. To do this, we use the matching table that was developed in the ESTIN and the ELF project. So this is the current situation right now. We are realizing these Inspire feature types, and we will make a specific GML application schema. If we had used a clean subtype, it would have been much simpler from an implementation point of view, because then we could have our planned land use Norwegian extension GML application schema only referring to the Inspire GML application schema. That would be very nice, but the current situation is that it's not that easy to do that. Okay, so conclusions and the summary. And our national law, our national act on planning is more specific, has stronger semantics, but except from this, it fits on a generalized level, and that is what we could expect actually. And on that generalized level, it fits better than we expected when we started the project. And there were no interest to weaken our semantics in the existing models to comply with Inspire. And I mentioned that currently we are using the realization relationship, including this matching table. And there is another pattern which we have not really studied so far. It came with UML 2.4. It's called redefine. It's a way where you can subtype, for example, from an Inspire class, and you can redefine some of the concept. There's no tool support for this, which means that we are not able to do that. We could make a nice UML model, but we will not be able to run shape change or anything to actually take the advantage of this mechanism. It's quite a new UML concept. It's implemented for attributes. It's not implemented for associations, for example, in Enterprise Architect. So it's still a way to go there. We will continue to examine the result from the Joint Research Center and the Geonovum Extension Pattern Project. There are more examples there. We will see if there are examples that we could apply also for our SULSI standard. And finally, my last conclusion here is that the Inspire extension rules are too strict. Thank you so much.
Thank you very much, Morten. I'm impressed with the system you have, with these SOSI standards that you have developed and for national use. So, do you have a reference to them from your national legislation, from the Planning and Building Act?
Yeah, we do. Yeah.
So everyone is actually obliged to provide their data according, their planning data, municipal level and regional level data according to those standards.
At all levels. I failed to mention that we have what we earlier called an advantage. We have our own transfer syntax. And most of this is actually handled according to our national syntax. That doesn't work anymore with the complexity we are talking about now, so this will be the first version where we'll actually use GML as the transfer syntax.
Thank you. Any other questions?
Yes, Nathalie Delat from Belgium. I'm really interested on your last conclusions, because we have this yesterday this GRC Geonovum pattern project. Well, can you give us an example why you think that it is too strict, or have you something in mind? Can you clarify a little bit this conclusion?
Okay, I think it from Inspire point of view. I mean, the Inspire directive, it is a legislation. It has to be implemented. There's no discussion about that. that as part of the legislation. But there is a lot of other data which would benefit from an alignment process. A lot of national and regional activities, even within the agriculture domain, we see that the reference Inspire. But I think that these very strict rules on extension will kind of scare some communities from actually applying this. So to weaken a bit these extension rules, it would make it easier to move or align in the direction of Inspire. So I think that would, I think that the Inspire and the European infrastructure would actually benefit from different kind of alignments, even if they are not that strict.
One more question, and then we have to continue.
Jan Bullens. Do you know if it's not a question directly, but more an additional remark to the previous question? So yesterday we had the discussions, and I know, Martin, we did that discussion as well, and I agree with you that there are some rules which will make it difficult to extend from the Inspire models and specifications. At the other hand, I think, and that's the challenge we have, you have to look for a good kind of balance in compliancy, which means interoperability between what is specified in Inspire and how you're going to extend. But I can see definitely the difference in when you use your own data in your own environment, then Inspire can be too limited to do what you do, and then you want to change it. So that's something which we have to figure out, and which is a difficult one.
Thank you. We're a bit behind schedule. Thank you for your active participation, and I hope that you can wait a short while before going for coffee, because there's one last presentation from my side, which is actually dealing with in a country if you have a situation where you don't have any standards. So how do you then harmonize planning data? This is an approach of Finland. So in Finland, land use planning takes place at the municipal and the regional level. The municipalities make the local master plans and the detailed plans, and then we have 18 regional councils in charge of the regional, or making the regional land use plans. And these authorities are the Inspire data providers, so it's up to the regions and the municipalities to provide the data. A bit of background, why is my institute, the Finnish Environment Institute, involved here? Well, we have a long tradition of cooperation between Syke and the regional councils. And in this presentation, well, I'm not focusing on the municipalities, only on the regional council cooperation. We have exchanged data sets from the 90s, before all our data were opened. There is already a community and a cooperation between the regional GI experts. They have annual meetings, usually at Syke's premises. In 2013, there was a project to jointly meet the deadlines of the Inspire obligations. That is, they jointly funded that one regional councils made all the data, all the WMS services, and all the data ethem feeds for all regional councils and jointly. And they would like to continue the cooperation with the deadlines that lay ahead. Already now there is a maintenance agreement that the Council of Southwest Finland has with the rest of the regional councils. And then when you come to the situations in the regional councils with the planning data, there are commonalities. They all use ArcGIS to produce their data. They also nowadays have moved to the same coordinate system. And of course, they follow the same legislation and guidelines. Difference is when you come to data is that the data structure and content differs very much. You can see here the amount of layers per land use plan. It differs very much from the regional councils. Here below, the regional councils and the amount of layers. Most of the regional councils maintain their data as shapes file, perhaps one shape file per plan marking, but there are also regional councils which have file geodatabases in use. The attributes vary a lot, the contents, and also the use of plan markings, the visualization, and which symbol they choose to use. And of course, Lapland is very different north of Finland from the south of Finland, so there is also a need to use a variation of plan markings. And also the GI know-how differs a lot, but in general you could say that it has increased quite a lot the last 5 years. So what then has to be done? Well, the regional councils want to improve the coherency of how the data is produced and the structure of it. And they really want this because they see that they can benefit it. If their original data is more similar, then they can get more, make the Inspire implementation more cost effective. Then they can continue the cooperation. And how would they like to do that? Well, they would like to identify and share best practices. What are the regions already doing, regional councils? And they, by taking the requirement into account, and by together agreeing on new frames, core things and procedures. And due to this, we set up a project called Harmonized Regional Land Use Plan, HAME, which started in October last year and lasts till the end of this year. And the main objectives are related to, first one is related to finding the needs and the requirements to the regional land use plan data. The second objective is to create a common database template. And the third one is to agree on a more coherent visualization and use of plan markings, which makes it easier to make WMS services. And as a cross-cutting theme across all these work packages, it was needed to make solution and guidelines that supports the implementation of the Inspire directive. The project setup is the following. We have Syke and the Regional Council of Southwest Finland that actually gets funding. And the expert team consists of all regional councils representatives, might be 1 to 3 persons per council. And they co-fund it because they use time to be present at workshop, to do testing, and so they are really important and active part of this project. Then we have a steering group. We actually have the chair sitting here, Marit Stenström from the Ministry of Environment, and they are funding this project. And then we have a sister organization of the regional council from that southwest region, also in the steering group. Going through these work packages briefly, as we needed to find the requirements. Well, we looked into legislations and guidelines, as Inspire was one of them, and we documented the status of datasets and services as they are today. Then we wanted to find out the user requirements related to data contents and the visualization, both from the internal users and from external users. We identified best practices from other countries and made kind of our own project target state. And the target state was more to together set up WFS services to be able to do that cost effectively in the future. And how did we find out the user requirements? We sent out the web repulse survey that was open only for 2 weeks. We sent it out to over 300 people, and we got 76 answers. So it was sent out to different sectors and to internal and external users. And since the internal users are the critical ones, in order to use this, we had this expert workshop to really double check the findings of the survey. And we did interviews with some external users. Well, our second goal is to set up a common database template. We used the outcome of the survey as a starting point, and then organized a workshop where we presented the Inspire planned land use data model and had some group work related to the findings of the surveys. 17 regional council was involved in this workshop. Then we had a smaller workshop where we looked into the master plan schema that has been done for municipalities, but since our focus was to do a common production database, we're not doing like a delivery for data delivery. We decided not to do a new schema, but to make a proposal for a data template. Our first version was tested by 8 regional councils, and we got a lot of feedback, and based on those feedback, we invited 2 regional councils to a smaller workshop. Then to be able to make an improved version that is out for testing now. And we had another workshop to really demonstrate how to use the file database because, as I mentioned, most of the regional councils are working with shape files still. And we made some new group work and hope to have a template in place in a couple of months. And there we will also do a UML class model of describing it, but it's kind of reversed engineering that we use the user requirements and going it that way instead. And an overview, this is now the file database where you see the main structure. This is for each plan you would have one feature data set, and here you have the zoning elements, the spatial plan, and all the supplementary regulations. So it kind of follows the structure of Inspire. Then we decided to include all compulsory and optional Inspire code lists as table, and they are also as domains here in the feature classes, so you can click, you don't have to write anything, you can use drop-down lists of the Hilux classes and drop-down list of the national plan marking regulation lists and so on. Now, a third objective was to agree on a more coherent visualization and use of plan markings. There is actually a plan marking guideline available, recommending some 100 plan markings for the regional land use plans. But the reality is that we have thousands of plan marking in use, even if the legislation that has been out there is only 15 years old, so there are thousands of these. And we have different visualization for the same plan marking, and same plan marking has been used to mean different things in different plans. So first steps towards this harmonized solution, we made an inventory of plan markings used. Not, of course, the full of it, but subgroup of the plans we went through. And we compiled them in an Excel file. You can see this is the recommended plan marking here, and all the visualizations of that particular that are in use in 15 plans. And then we asked for preferences and arguments on which one to agree upon of these from the regional councils. We made a first proposal based on that and had the expert team to make some group to collect further feedback. And we hope to have a final joint proposal in a month or so. And when it comes to Inspire, well, I've been referring to it on the way, but the content and the structure of the common database template supports the implementation of Inspire in many ways: feature classes, attributes, and code lists. And we have also made guidelines on local IDs and how to build them up so that they have a community and a common agreement on how to deal with them. We have set up guidelines and proposals related to code lists and made a proposal on the compulsory plan type name code list for Finnish regional land use plans. And we are in the process of setting up a mapping table between the 100 plan marking guidelines and the HILUX and the other, the supplementary regulation code list. So my findings and conclusions are that the digitalization programs like e-government and Inspire really has helped to understand the need for harmonization. And in general, the Inspire requirements are in line with other user requirements in the national requirements. But to achieve a full automatic mapping of these diverse plan markings to Inspire code list, it's not possible to be done. So some manual work will be needed. And one of the findings that, at least in Finland, the supplementary regulation code list corresponds better to the plan marking than HILUX. So we are thinking about using both. At least in protected sites, it says in the technical guidelines that you are supposed to use first HILUX to say, well, this is class other, and then point to a class in the supplementary regulation code list where it's specified that it's protected area. So we're wondering if we could do that kind of double thing for also other plan markings. So these are our first steps towards Inspire compliant data sets for the regional land use maps. We are building the foundation and strengthening the community, but of course there's a long way to go. But luckily there's a bit more time with this Annex 3 deadline in 2020. Okay, thank you. Thank you very much. Any questions related to this project? Approach. If not, I will actually, I would like to very much thank all the, okay, can I see it? The presenters of today. It doesn't work. And thank you for your very active participation. And I made a final slide of other presentations coming up during the conference. So there's a lot of presentations related to land cover and land use coming up the next few days. I'm also arranging a land cover and land use cluster meeting during the coffee break on Thursday. So you're welcome to join there also. Thank you very much for your active